Good afternoon, everyone. What we have seen in the previous session, yeah. So until now, we have seen two exercises. One is using pointers, call by value and call by reference. We have done, and the last one is dynamic memory allocation. We have done malloc, calloc, realloc, and free. Right, we have worked with those functions. So for that, which is the header file which I have to import? If I want to use DMA, what is the header file I have to import? Which header file has got malloc, calloc?
Studio library.h.
Yeah. Yes, std lib, that's standard library.h. Yes, it's correct. Fine. So in today's task, it is. I'll just share my screen first. Yeah, the task over here is to implement a binary search tree concept. So we have just done with these two tasks first, right? Pointers and DMA, and then starting from stack, queue, and linked list concepts, single, double, circular. So all these things comes under unit number 2, right? So this you will be practicing with Jaser. All right, and so here this starts from unit number 3, which we are getting in right now. Like we have already done in order, pre-order, post-order. So in unit number 3, we have only 2 tasks. One is binary tree, and another one is like performing in order, pre-order, post-order. Hope you are aware about this. So here we need to do that one both in recursive and non-recursive trees. So basically recursive thing we have done. So still we will look into this. Fine. And then all these things comes under unit number, that last unit, 5. We will practice all these sorting techniques. Queue, merge, bubble, and we will implement binary search also. So these are the things we need to get into. So today we will talk about binary search tree again. So before that, so tell me, what is a binary search tree first of all? What is a binary search tree? When we will call a tree is binary search tree? Okay, so the root of a parent should have less, I mean, what do you call that, lesser value than the root in the left side, and then greater value in the right side. So in that way, and it should not have more than 2 children, right? Okay. So how can we implement this in a, I mean, we know this concept, but how to do a program, how to make a C program, using which concepts we can apply here. So now what are all the elements in BST? Main elements. Which means we need to have a data, I mean the value, and then we need 2 pointers like left and right, and then always we need to check with the root. I mean first the root value is 10, if suppose, then I want to insert 12, then what should I do? The first element inserted is 10. I mean before inserting, first we will check whether it is null or what, empty or what. Anyhow, it is null. So if it is null, then what we have to do? No, first of all, there is nothing. There is no tree. But I want to check whether is there any existing tree is there or what. There is nothing. Then what it will print? If it is not, I mean, if tree is empty, then I should display some message. Tree is empty. You have to allocate memory space first. Then insert tree like that. Then what we will do is that we will say, okay, create. We will call create function. In that we will mention malloc or calloc. Then in that we will specify n size. I mean, the user can enter that size during runtime. How many elements you want in this tree? 10. Then you have to take 10 elements. You have to enter 10 elements. Then, okay, now you have entered 10 elements. I mean, passing the value to malloc. So it will create. We have seen that in the previous lab I have shown you that some array type of thing it will create. So malloc will create one single block. Calloc will create the contiguous blocks like array, right? So I have entered 10 elements like 10, 20, 30, 40, 50, like that, 100 up to 100. So it is allotted. I mean, it got stored in that. Now I need to represent this one in after getting stored. So by using binary tree, we have done these operations like in order, pre-order, post-order. So now I want my program to do these three operations from the input which I have accepted from the user. Already there is input, it is stored. So now how to do that? In order, pre-order, post-order for a given value in a program. So again, we know that what is in order. What is the rule? In order in the sense, should I visit root first? Or I should go to left or I should go to right? What is in order? Sit. Root, left, right. So, guys who are online, can you confirm? What is in order? In order comes with?
Left, then root, and then right.
Left, root, right. Is that fine? In order, left, root, right. No? Then so which means I have shown you one algorithm while I'll share that one first. So this is what we have done, right? There were three traversal methods. In order, that is left, root, and right. For post order, we had to do left, right, and root. In pre-order, it is root, left, and right. Okay. So what I have done here is that, so in this way, for example, there is a tree, and then I just want to say traverse this one in pre-order mode. So first I'll visit root, fine. Then I'll go to the left child. Then if there is anything towards that left, then I'll visit that. Then I'll go to the right. Okay, so this is done. Then I'll go for I'll go to the root, and then I'll go to the next part. So this is how we have done. So now the algorithm is simple like this. So for a particular tree, what you want to do is that first you have to visit the root. Is it? So and then you will, in pre-order, we will visit after root. We will point toward. This is like the tree should be pointed towards left, and then once the left thing is done, then it should be pointing to the right. So because why I'm talking these things in the sense, like we will use struct. In C, I think you have done structure. You might have heard about structure. So struct. So before getting into that, I was asking you some question. So how many members I should use in struct? Like you will say, I mean, we can have different data types, right? Yeah, 3. So what are all those 3? Yeah. Yes. So I need to have a data and then left and right pointer, right? Because whichever, because I need to direct my algorithm to go to left or right based on the order which we have selected, which we have selected. So we're going to perform all these 3, like in order, pre-order, and post-order. Okay. So even that is also given in our experiment. Uh, Here it is. We're going to do that tree traversal. And yeah, in binary search tree, I want to show you that you can perform all these activities. So these are all the operations which we can perform in BST. What are all they? So one is like initializing, and one is if you want to search something, search some element. You have 100 elements. I want to search for a particular thing. Then you can do that. And then if you want to, make empty, we will simply say free. In dynamic memory allocation, we have used free, right? Free is a particular pointer. We just call that, it will be empty. Then if you want to insert further any nodes, then you can use insert method, function, delete, create, finding minimum value from the whole, uh, tree. We have done that one, today's task. While deleting 2 children, you have to go for, either in the left side, we have to find the maximum one, and in the right side, we have to find the minimum one. So, so we can do that one in a programmatic way also. Like we can find minimum and then we can find the maximum value also. Fine. So these operations can be done in BST. All right. So just give me a minute. I'll reshare my screen again. Who is Urvil? Urvil. Urvil Mehta. Just left the session. Okay. So don't be late, okay? First 20 minutes are crucial, which means in all the labs I'll be explaining the program. Then you'll be trying the program. If you miss that session, then it's very difficult. So please join the session by 2 o'clock. You can take 5 to 10 minutes, but you have to be there in the session at least by 2 o'clock. I'll take 1 more minute and I'll share some code for you. Just allow me to fetch that particular file. Okay, so I'm gonna share my screen now. Fine. So hope you can see my screen now. So as I said that I have used a struct over here, and you see this. I have taken three, you can say, numbers. Like one is like I need to have I need to pass data, right? I mean, some elements should be stored in that, and then I have kept that as data. Then I'm gonna have left pointer and right pointer. Okay, so I'm gonna call this as node. So in future I'll refer this as node. So here what I'm trying to do is that first I need to create a tree. I mean, the create function will make you to assign, I mean, the space, and then within that I'm gonna insert, right? It is going to create. We are going to allocate memory space, malloc, this much. Okay. Then and then I mean I'm asking this that particular struct to create this. Fine. So and then we gonna do insert and pre-order here. So it's up to you. If you want to do in order, then you just want to change the syntax, in order, pre-order, or post-order. So in the main function, you just declare the variables which is required, and initially I have kept root as null, and here we will use a temp variable where because if you want to point something, then once a particular element is inserted, after that the temp value is going to change, right, for every insertion. So what I'm trying to do here is that, so I'm saying that initially it is, I mean, I'm assigning it to the temp. That is, I'm going to create something. So if root is null, then it is going to be, I'm assigning again root equal to temp. If not, then it is going to insert. Which it is going to insert? I'm going to ask the user to enter some values, and then I'm going to take that one. Then it is going to, you know, I'm going to say yes or no. If you want to insert, then you have to press yes. Then you have to keep on inserting. Fine. So here I have called some function, and then I have passed this root. So which means I have given some definition over here for both insert and then pre-order. Fine. So and then I have called a create also here. Is it? So which means that I'll first we need to create a memory space. For that, we know that how to create a memory space, right? I mean, we need to allocate memory. So you can use malloc or cloc for this. So again, for that, so here I say that, as I said that we're going to use a temp over here, and then I'm just assigning some size of node using malloc, and then whatever the size which is entered by the user, which was taken, and then this syntax we have seen that, like for temp, we initially I'm saying that left equal to temp, it should point right equal to null, which means that here the memory will be allotted and that will be returned. Then in insert, it is going to ask the user, I mean, the user will be asked to insert some data, right? Here it is. It is going to do in a recursive way. So we have here do while, which means here the insertion should happen either in left side or right side. Is it? Do you agree with that? I have a root. Then if I have an element, then either it should go left or right based on you know, whether it is less than or greater than of that root. Is it? So here we're gonna do the same. So this is for insert function. So if the temp value, I mean the value which is entered by the user, that is data, less than root, in the sense it should go to left side, is it? So root, now it should point to the left side, and then it should insert that. If not, it should go to the right side here. So this is what we're gonna say in this. So this is common for a common step which we follow here. Then again, now you know the syntax for pre-order, which I have already shared here. What we will do in pre-order, either we visit root, yeah, so we will visit root, then left and right. So that is what given here, na? So I'll just apply the same here, right? So I'm just saying that this function pre-order, first I'm checking whether the root is null or what. I mean the tree is empty or not. If it is not null, in the sense it should have some data, is it? Then it should be taking root first, and then it should go for left and right, then it should print. So basically we have three functions here. One is create for allocating memory, and then another one is for insert to enter your elements, and then after entering, that should be that should process in the pre-order mode. Then if you want to extend this code further, like if you want to do in order in this, post order in this, we just want to change it over here. I mean this order should be changed, that's it, is it? So now it is root left right, then you have to say left root right. So we just want to change this order here, that's it. So it is going to work. Let me run this. So I'll say I'm not sure whether it will execute until that I experience some slowness in this. I'll say 99. So you can go for n number of elements like this, and I will say n, no, which means now it should display the 44, 77, 22, 99. So based on these values, it should arrange this one in pre-order. Then it will display the result here. Okay, so I should let me run this again. Oops, I'm mistaken. Yeah, it's trying only once, but it's just keep on printing. Say so that is the concept, right? I mean, you just want to give the values, and then it will print those values in pre-order. So based on your the sequence which you have mentioned in the code. So now what I want from your side is that you just try a basic program like this. Like you need to create a binary tree using struct. Yes, so it will consider here. That's what we have written here. Let me show you that. It won't show you a graph kind of thing here. It will just tries to find the what do you call that, minimum number should be sorted. Anyhow, finally we are going to get the sorted order, so it will simply sort it, because we are comparing here like that. I mean, so here if in this section we will compare, if the data is less than the root, then it should go to the left side, or it should go to the right side. Then finally all these elements will be stored in a I mean sequential way. So then that can be traversed in pre-order mode, because of online. I can try the same in offline. I'll show you. So now you please start try to implement this program, and I'll show you once it was done in an offline compiler. Fine. So the thing which you want to do is that you need to implement binary search tree concept. Okay, so you can go for the references. Then you can see that a lot of references will use the similar kind of concept. So they'll be using struct, and then they'll be having data left pointer and right pointer, and then it can be done. And try this one and share your screen. So you can apply, you can do like creating a binary search tree, or you can also implement in order or pre-order or post order, or just a binary search tree is also enough, because the task is to just create a binary search tree. So those who are online, please give a try. Don't be idle. Okay, the task is to implement BST. So uh, hope you have got the concept. Please give a try. So I'm just sharing my screen again to display the output. Okay. So I just tried with. Hope you can see my screen now. Yeah. So the same program. I'm just going to run this. Okay. So let me enter some data. That is, I'm saying that. Uh, okay. Let's take the first output, which is displayed here. Take 66. Let's say yes, and then I'll say 44, and I'll say 1. Yes. Then I'll say 77. Yes, and I'll say 99. I'll say no now. Oops. I should use get.ch so that I can halt the screen. So now the output is displayed. So can you just correlate this output with what happened here? My values which I have entered here is what? What I have entered first? 66, right? 66, 44, then 1, 77, and then 99 I have entered. So what is the pre-order? Answer is, it has given why it is same. So I have given an input here, right? This is my input. So if I construct a BST, so what should I do? 66 first, that is the root. Then what is my second value I have inserted? It should come left, 44. Then yes, then 77, 77 like this. Then 99. So now what is the pre-order for this? One four four six seven seven nine. Should I visit like that? It should be pre-order. Should be root left right. So the answer should be like first I have to visit root 66. Left is 44, and then again further I have left 1. Then there is nothing else. Then I have to go right. Then 77, 99. I'll be getting right. No, for pre-order it is. If you change the order, it will be changing. You can try in order also in this. Just put that print statement in above that. It will work. In order, post order you can try. So just change it and you'll be getting it. You can try with different output. I'm just giving you a sample here. Okay. So which means in that pre-order, I have just mentioned that 3 orders. First, you should go to root and left and right. So for other orders, it changes, right? You have to go root first or left, right, root. That. Okay, let's try. Three. Say 8. 25. 23. And let me say 99. And what else? 27. Okay, no. And now what happened? So if I construct a tree again, what happens? Yes. So will I get the same order, or it should be different order? If I apply a pre-order for this input, 3, 8, 55, 23, 99, and 77. Can you draw that in your sheet? I think I should get. It should be in sorted order, right? No?
Input you change is 77 and 99. That's right.
Okay. Okay. So I need to say 3,
8, 55, 77.
where is the number? Yeah, again it is in sorted order only, right? Now for this, what is the answer for this input? What is the answer for pre-order? 3, 8, 55, 77, 99. You include 23 and tell me what will be the output, then I'll try.
Output is correct.
Uh,
But we are entering the perfect way as it is.
yeah, that's what pre-order. You just
I just want to try it that we will
okay. Let me try with 23.
change the value and then we get to
Okay.
or not.
Okay. So now what should I try?
3,
3,
8, 23.
8. Done? Okay.
55.
How it is done?
77.
It is done.
No. 77. 99.
Wrong? Why? So how? So 3, 8, 23. No, I didn't insert 55. Yeah, I have inserted, but I have inserted 23 first. 3, 8. Sorry, I mean my input is 3, 8, 23, 55, 77, 99. My input is like this. 3. I have given the sequence like 3, 8, 23, 55, 77, 99. So first I'll take this one. Then 8.
23,
Yes, 23.
65.
All will go like this one. This is skewed, alright? Yeah.
Sir, but if we interchange this,
The output is different. So which means what you have given is skewed. I mean it goes one side. Right? This is right skewed, left skewed, skewness. In that way it is not getting, if it is skewed. Still we can try with left skewed also. Then it will be providing the same. Fine? Now again there is one more task for you. So let me share my screen once again. I'll just demonstrate those three things. We have done only one now. I have shown one traversal order. I'll show the rest of the two. Then you can compare with all those three. Yes. So hope you can see the screen. Program goes like same. I have a struct and with three members like data and then two pointers, a right and left pointer, and then I'm creating three functions. One is for in order, pre-order, and post-order, right? And one is uh, to create that particular tree BST. So the coding is going to be same, but I have altered it. So let me run this first, then I'll get it to the code. So here I'm just displaying. I'm using switch case here because we have to do in order, pre-order, post-order. So I'm asking the user to select which order he wants so that that can be performed. So first it is asking to create BST, right? So I'll say my choice is 1, and it is asking how many nodes I want to create. I mean, I need to have, let me say 5. And so I'll just enter node number 1, that is 65, and node number 2 is 45, node number 3 is 75, and node number 4 is 5, node number 5 is something like 95. 5 nodes. What happened? It's clearing my screen, okay. Okay, so I'll go with again. 5 nodes with 67, 77, 37, 47, 97, something like this. So now it is asking me, see, BST with 5 nodes is ready, right? 5 nodes are inserted in the tree. So now you can select the traversal order. For example, if it is, we have done post order, right, in the previous program. So I'm gonna check with post order. It is 47, 37, 97, 77, 67. So if I go with in order, sorry, the choice is 2. And it's what in order. And pre-order is going to be like this. So simple thing. Again, I have done 3 lines that post order. I have changed that to root left node. Just altered it. That modification is required. That's it. Which means if you do one traversal, the rest of the things are easy. So I can show you that again. What I have done. I'll go to the method, right? Exactly. See here. If you compare this, there is nothing. Just post order, and then I'm saying I need to go to left, right, and the root. Then the same function I have just copy pasted, but renamed it to pre-order, and then here I just rearranged it, root, left, and right. And for in order, I've done left, root, right. Then I have called these 3 functions here in the main program. I mean, when I want to select this choice, case 4, I've called that pre-order, and I'm passing the root value. I mean, that values 5 values which I have entered. And then if it is case 3, so you can do it, do the program in any ways. So it's your style of making. So try this one. If not, then I'll share the coding part to you so that you can, alter. I wanted you to try first. So is there any update from online students? Hello? Have you guys tried binary search tree? coding part is in chat box right now. You have to organize and then execute it. Once you are done with this, so here only pre-order is implemented. You just implement in order and post order. It's very simple. We just want to change the order, and you have to introduce, new function here instead of, a pre-order. You should say that it is a post order. Then, alter this steps. Either you want to visit left, right, and root or what. You just put it in that way. Then you have to call this particular method here. Where I'm calling over here. So I'm just here. I'm printing it, right? So first you are printing pre-order, then post order, then in order. So something like that you can use. Or if you want to ask for the choices from the user, then you can go for switch case. Then where you can give options for the user to select which particular choice he should select. So in that way also you can implement. Fine.